we're going to learn about being able to use the techniques of antiderivatives to be able to find the antiderivatives and then to check them. And so it might be handy to have a list of those antiderivatives that we just found in the previous section. All right, so maybe have these written down somewhere so that way maybe on a flashcard so you can try to reference them quickly. Our first one that we have, f of x equals 7x to the 6th. And we have our general rule for any sorts of terms with an x to a power in it. We have that the antiderivative, if f of x is equal to x to the n, the antiderivative is x to the n plus 1 divided by n plus 1. And so in this one, and of course there's the plus c. So in this one, what we have is we're going to take the antiderivative to be equal to 7x to the 6 plus 1 divided by 6 plus 1, all right, just by using this general rule, which is the same thing as 7x to the 7th divided by 6 plus 1, which is 7 plus c, which is the same thing as x to the 7th plus constant c. Right? How do we check this? Right? Well, what we're going to do is we're going to find the derivative of our x to the 7th plus c. And we know that that's going to be 7x to the 6th plus 0, right? Because c is a constant, and we know that the constant, the derivative of any constant is 0, and that's just 7x to the 6th, all right? And that's the exact same thing that we just started with all the way back up here, all right? So now if those don't match up, that means your antiderivative is incorrect, all right? So this is the antiderivative. A second example, we have a function f of x equals 7 sine x plus 6, and we want to find the antiderivative of that. Right? So we go back up to our list, and the 7 can just stay there. Now the antiderivative of sine is negative cosine. So I'm going to say cos of x, and I'm going to put the negative in front of the 7. Right? And of course, when we find the derivative, we can check this. We have a constant. The derivative of any constant is 6 times the variable that we're taking the antiderivative with respect to. And then finally, we have our constant c. Now, how do we check this? Well, we take the derivative of f prime, capital F prime. Now, we know that the derivative of cosine is negative sine. So this is going to be the opposite of negative 7 sine x. The derivative of 6x is 6, and the derivative of constant c is 0. All right, so these are our derivatives, and then we know negative times negative is positive, 7 sine x, and then 6 plus 0 is 6. And notice that 7 sine of x plus 6 is the same as 7 sine of x plus 6, so this is our correct antiderivative. A third example. This one's actually pretty tricky, right? It's just 8, and we want to find the antiderivative. Now, this is what most students would do, or a lot of students, excuse me, I don't want to say most, but they would say that the antiderivative, now it's already capital G, all right, so I'm just going to call this, let's see, I can just call this GA, G antiderivative of T is going to be equal to 8T plus c. All right, a lot of students might do this, 8x plus c. But notice that the variable is with respect to t. All right, so you have to be careful with that. Now we're just going to find the derivative to check it. So I'm going to call this GA prime of t. We know the derivative of 8t with respect to t is 8, and the derivative of constant c is 0. And so that just becomes 8, which is indeed the original function. All right, so this is our correct antiderivative, 8t plus c. Right, a fourth example. Now this one's a little bit sneakier, all right, just because we have this y to the 12th in the denominator. And it looks sneaky, but it's really not, because we're just going to use the exact same techniques for differentiation. And you might remember that one of the things that we can do is we can just rewrite this as a negative exponent and pull it out of that denominator. And now what we can do is we can just use the general rule for antiderivatives. Right? So capital F at y. The negative 11 is just going to come over. That's y to the minus 12 plus 1 divided by minus 12 plus 1 plus c, which is equal to negative 11 y to the minus 11 divided by minus 11 plus c, which is equal to y to the minus 11 plus c, or 1 over y to the 11th plus c. All right, now that's our antiderivative. And this is an 11, not a y double prime, just to be certain. But of course, we want to check this. All right, so let's take the derivative of this just to make sure. All right, so I'm going to erase all this just so that way we have a little bit of room to work with. And, all right, so we're going to hold on to that. And so remember, our antiderivative f at y was 1 over y to the 11th plus c, which is the same thing as y to the minus 11 plus c. And if we want to find the derivative, I'm going to call that capital F prime of y. That's going to be negative 11 y to the minus 12 plus 0. And then we can just swing that to the denominator by making it a positive exponent. And notice that this is exactly the same. All right, so this is indeed our proper antiderivative. All right, one last example, and this one's pretty easy. We have 17 over r squared plus 1. All right, now a lot of students might think of this as 17 times r squared plus 1 to the minus 1 based on what we just did. However, a better way to think about this is you can think about this as f at r is equal to 17 times 1 over r squared plus 1. And why is that helpful? Because 1 over r squared plus 1, or 1 over x squared plus 1, has a basic antiderivative. So if we go all the way back up, that's your arctangent. And so when you write the answer, you can write this as f, capital F at r, is going to be 17 arctan of r, not x, but r, because our function's in terms of r, plus c. And then, of course, if you want to find the derivative of this just to check, well, f prime at r is going to be equal to 17. Derivative of arctan is 1 over 1 plus r squared plus c, or plus 0, excuse me. And we know that that goes away. Obviously, the sum can be written as r squared plus 1 if we chose to. And so it does indeed equal what we suggested initially. All right, so the correct antiderivative is going to be this arctan of r times 17 plus c. So hopefully that gives you an overview as to how to utilize antiderivatives to find all the techniques. Now, in the next series of videos, we're going to be taking a look at the idea of an integral. And really, an integral, to be able to evaluate it, is just going to be an antiderivative. However, an integral really does represent a lot more than just an antiderivative, as we'll see a little bit later in the course.